All right, let's just dive right in. We're about to explore one of the most mind-bending, reality-warping ideas in all of science. An idea that could completely rewrite the story of our cosmic origins.
We're all taught that the Big Bang was a singular, explosive moment, the start of everything. But what if that's not the full story? What if it wasn't the beginning at all, but just a chapter in a much, much bigger book?
And let's take that a step further. What if our entire cosmos, everything you see, every star, every galaxy, is actually contained inside the event horizon of a black hole? A black hole that exists in some other, older, parent universe.
Now, before you click away, I know this sounds like something out of a sci-fi movie, but I want to be really clear here. This is a theoretical model called black hole cosmology, and it's a serious attempt by physicists to solve some of the deepest puzzles we have about our existence.
So, you might be asking, why would scientists even consider something so out there? Well, it's because the standard model of the Big Bang, as successful as it is, has some major cracks in its foundation.
See, at the very heart of the Big Bang theory, you run into this thing called the singularity. It's a point of infinite density where all the known laws of physics just stop working. They break down completely. Science literally can't describe it, and that's a huge problem if you're trying to explain how everything began.
So this gives us two competing starting points. The standard model has this singularity, this mathematical dead end we can't explain. But black hole cosmology, it replaces that with something called a big bounce, a moment of absolutely incredible but finite density. It's not a breakdown of physics, it's a transition. So how does a bounce like that even happen? Well, the secret ingredient is a property of space-time called torsion. You can think of it like this. Gravity is always pulling things together, right? But this theory says that when you squeeze matter to an almost unimaginable degree, the quantum spin of all those particles creates this powerful repulsive force, torsion, that acts like anti-gravity, pushing everything violently apart. And when I say squeezed, I mean squeezed. Torsion only really kicks in at densities around 10 to the power of 50 kilograms per cubic meter. I mean, that's a number so huge it's almost meaningless. It's basically the density where matter itself just says, nope, that's it, I can't get any denser, and pushes back. Hard. Okay, so let's walk through it. Here's how you could build a universe. First, matter collapses inside a black hole in a parent universe. But instead of forming an infinite singularity, it hits that absolute density limit we just talked about. Right then, torsion kicks in like a cosmic spring, violently flinging all that matter outward in a massive expansion. And that expansion, well, that becomes the Big Bang for a brand new child universe. Our universe. All right, so that's the theory. It's a pretty neat story, right? It solves that whole singularity problem. But is there any actual evidence? This is where we have to become cosmic detectives, looking for clues hidden right here in our own cosmos. And here's a really fascinating puzzle. If the Big Bang was just a random explosion from a single point, you'd expect everything to be pretty random, too. You'd think galaxies would spin in all sorts of directions, about half clockwise, half counterclockwise. Makes sense, right? Well, it turns out that's not what we see. Not even close. Recent data from the James Webb Space Telescope looked at hundreds of early galaxies and found something startling. About 2/3 of them are spinning in the same direction. That just shouldn't happen in a universe born from a random event. So what on earth could explain this? Well, here's one mind-blowing possibility. Our universe might have inherited its motion from being born inside a spinning black hole. Just think about it. Like a whirlpool creates a vortex, the spin of the parent black hole could have imprinted a preferred direction, a sort of cosmic axis, onto the very fabric of our new universe. And the potential beauty of this theory doesn't stop there. Its supporters argue it can also explain some other massive cosmic mysteries without needing extra tacked-on ideas. Things like cosmic inflation and dark energy. This model suggests they just pop out naturally from the physics of the bounce. It also makes a prediction we can actually test, that our universe isn't perfectly flat but has a slight positive curve. But okay, let's pump the brakes. This idea is really, really far from being accepted science, and it faces some serious hurdles. We have to be honest here and look at the case for doubt. Looking at them side by side, you can really see the trade-offs. The standard model seems simpler on the surface, but it has to rely on these mysterious, unproven add-ons, like an inflation field. Black hole cosmology is way more complex. I mean, it needs a whole parent universe. But in return, it offers these built-in explanations. In this view, the multiverse isn't some weird side effect. It's a core feature of reality. One of the biggest criticisms is pretty straightforward. Since we can't see outside our own universe, how could we ever truly prove any of this? As one scientist put it, it can feel a little like an educational guessing game. If the main components of your theory are forever beyond our reach, how can you ever really test it? And yeah, the list of problems to solve is pretty long. You've got fundamental issues like Stephen Hawking's information paradox. What actually happens to information that falls into a black hole? You've got observational puzzles too. Like if our universe inherited a spin, why don't we see a huge centrifugal force flinging galaxies to the edges? Plus, some predictions from related theories have already run into trouble with data from neutron stars. These are not small issues.
So where does that leave us? Well, this idea is definitely not settled science, not by a long shot, but it represents the thrilling, bleeding edge of theoretical physics. This is truly cosmology's new frontier.
So the verdict for now is pretty clear. Black hole cosmology is a compelling but totally unproven hypothesis. It's an elegant solution for some big problems, but it creates a whole bunch of new ones. It's a very active area of research, but for now, it remains a fascinating what if.
But the story isn't over. Scientists are actively working on this stuff. The James Webb Telescope is going to keep gathering data on those galaxy spins. The upcoming Euclid mission is designed to measure the curvature of our universe with incredible precision, which is a direct test of one of this theory's key predictions. The work definitely continues. And that leaves us with one final, just staggering thought to chew on. If this theory, or something like it, turns out to be true, it means that every single black hole we see in our own universe isn't an endpoint. It's a beginning. It's a seed for a new cosmos with its own Big Bang, its own galaxies, and maybe, just maybe, its own life, wondering where it all came from.